Hello, everyone, and welcome to our deep dive into Amazon Elastic File System. I'd like to thank you all for joining us today. My name is Duncan Lennox. I'm the Director of Product Management for Amazon EFS, and I'm joined by my colleague, Vince Carrion, a Senior Product Manager on the EFS team. And we're also really fortunate to have a builder with us today, a customer from T-Mobile who's going to talk a little bit about how they're using EFS later in the session. We've got a lot of great material we need to cover with you in the next hour. We'd like to start out with a little bit of an overview of AWS storage, give you a sense of the options that we have available and how we think about storage at AWS. And then I'm going to turn it over to Vince to give you an introduction to Amazon Elastic File System. And then we're going to dive deep into EFS and share with you a lot more of the details about the capabilities of EFS. Then we'll talk a little bit about customer use cases, how our customers are using EFS today, wrap it up with some best practices, some guidelines for getting started with EFS, and then take your questions at the end. So let's get started. Let's dive into the AWS storage overview. So AWS has been innovating with storage rapidly over the last decade, and we are really excited that Gartner and their clients have continued to recognize our leadership. On the public storage Magic Quadrant, we're the vendor that is the highest on both axes, and we've been there since day one. And being out dealing with storage at scale with our customers has allowed us to gather a lot of feedback about storage and storage needs. At AWS, 90 to 95% of our roadmap is driven by the feedback we hear from you, our customers. And it's allowed us to build a storage portfolio that's broad and deep. And in the almost 13 years now that we've been working with customers, helping them move to the AWS cloud, we've learned a lot about adoption patterns. And we see three core adoption patterns out there with our customers. The first one is rehosting. And this is where you're taking an existing application that might be running in virtual machines and moving it directly into the AWS cloud. That's how we help Lionsgate, for example, take their SharePoint and SAP applications and move them into the cloud. Another pattern we see is replatform. That's where you're taking an existing application that you have, moving it into the AWS cloud, and taking advantage of bits and pieces of AWS services, including Amazon Elastic File System. That's how we help the BBC take their red button application and move it from on-prem into the cloud. And then the third pattern that we see is re-architecting. And this is where you're modifying an existing application as you move it into the cloud, and of course building new applications for the cloud, and leveraging a storage service like S3 through our APIs. And getting all this feedback from customers and working with them has let us build out the options that we have for you. And what we want to be able to provide to you is more choice so you can select the right storage solution for each of your use cases. So whether that's a block storage service like Amazon EBS, which you might be using in rehosting, or file storage, of course, like Amazon EFS for replatforming, and then re-architecting with something like Amazon S3 or Amazon S3 Glacier. So why does file storage matter? Well, really, when we're talking about file storage in this context, we mean network file storage. And of course, the vast majority of data that you have today is unstructured file data. You have a lot of applications that are depending on file and file systems. So having services available from AWS that provide file system services natively allows you to take those applications that you have today and move them to the cloud without needing to rebuild core components that sometimes are going to be costly and expensive to re-architect, or you may not even be able to have that as an option depending on where the components come from. So we're providing services that enable you to take those existing applications and your existing IT environments and move them into the cloud. So let's talk about fully managed cloud systems. So Amazon EFS, of course, is what we're going to do a deep dive into today. But just yesterday at reInvent, we announced two new fully managed file service options that we have available. Amazon FSx for Windows File Server and Amazon FSx for Lustre. So Amazon EFS is a general-purpose cloud-native file system designed for Linux workloads. It's an NFS-based service. Amazon FSx for Windows File Server, then, is designed for your Windows workloads. It delivers Windows-native capability in a fully managed service. And Amazon FSx for Lustre is designed for your compute-intensive applications. It's based on the popular open-source parallel file system Lustre, but it's fully managed. So today, we're going to focus on Amazon Elastic File System, and I'd like to turn it over to Vince for our deep dive.
Good afternoon. My name is Vince Caron. I'm one of the product managers on the Amazon EFS team. So I have a lot of insights and a lot of stuff to go through. So let's start with an introduction to Amazon EFS. So a couple years ago, we launched Amazon EFS. And before EFS, if you wanted shared file system in the AWS cloud, you had to do it yourself. So some of you may be familiar with an architecture similar to this in doing it yourself. And to do this, it could be pretty burdensome, definitely a lot to manage. First, you had to manage the file server, you had to manage the storage volumes, and then you also had to worry about replicating that data across availability zones to ensure for high availability. So we launched EFS, and we had a couple things in mind when we did it. So first thing we wanted EFS to be, we wanted it to be as simple as possible. Amazon EFS is a fully managed service. It provides a simple interface for you to create and configure your file systems and manages the file storage infrastructure for you. And with just a few clicks, you can create a petabyte scale file system. Talking about elasticity, that was our second core tenet that we wanted EFS to be. So EFS file systems automatically and instantly scales your file system storage capacity up and down as you add or remove files. There's no need to provision storage. And the last tenet is we wanted EFS to be scalable. As I just mentioned, with just a few clicks, you can create a petabyte scale file system where throughput scales as well. So we'll talk about each of these in a second. And on top of all of that, we wanted EFS to be highly available and highly durable. So now that you know a little bit about their tenets on how and why we built EFS, let's go into some of the features of the service. But before we do that, I wanted to talk a little bit about the service in the past year. So as you can see from reInvent 2017, it's been a pretty busy year for the EFS team. We've launched more features, launched EFS into more and more regions. As you can see, we expanded to the Northern California, Seoul, Tokyo, and Singapore regions. We launched encryption of data in transit. We launched a new feature called the provision throughput. And we earned more and more certifications and provided more ways for you to access that file system. So I talked a lot about a number of these. We'll get into these in just a moment. So you're here today to learn a little bit more about Amazon EFS, and we'll talk about each of these. Again, starting with elasticity and scalability. So again, you can grow and shrink your file system on demand. In fact, there's no way to provision storage. You simply just add or remove files, and EFS manages it for you. You can grow your file systems up to petabyte size. There's no provisioning, as I just mentioned. And in the default bursting throughput mode, your performance scales as the file system grows. And we'll talk about that in a second. And lastly, in terms of scalability, you could also mount thousands of instances with concurrent access to a single file system. Amazon EFS is designed to be highly available and highly durable. We're designed for 11 nines of durability. And the distributed architecture of Amazon EFS provides availability and durability protection from AZ outages, system failures, or network connection errors. We'll talk about the distributed architecture in a little bit in terms of our best practices, and that'll be towards the end of the session. Again, you can mount your file system across multiple availability zones. We offer strong consistency for concurrent access, and your data is replicated within and across multiple availability zones, again, adding more layers of availability and durability. Another benefit of Amazon EFS is the ability to access your file system from a number of different locations. So first, you can access Amazon EFS through EC2 instances in your VPC. You can also access the file system via AWS Direct Connect to your on-premise servers. In October, we announced that you can now access your EFS file systems from on-premises servers using AWS VPN connection, as well as EC2 instances using intra-region VPC peering. And just this week, we announced that you can access your EFS file systems from EC2 instances in other AWS regions using inter-region VPC peering or via the newly launched AWS Transit Gateway. And in fact, just yesterday, we announced that you can now access your EFS file system across accounts using the new shared VPC. With this, we've increased the number of file systems that you're able to create per account. As you can see there, we increased that to 1,000 file systems per account, or a 10 times increase. And we've also added a new limit of 400 mount targets per VPC. So Amazon EFS has two different performance modes. You have to pick the performance mode when you create the file system. So let's talk about both of these. The default is the general purpose mode. And this is what we recommend for the majority of customer applications. And as you test your application with EFS, this is where we recommend that you start. The other performance mode is our max I/O performance mode. And this is really recommended for scale-out workloads. So let's compare and contrast the two different performance modes. Let's start with what's it for. The general purpose performance mode is designed for just that, general purpose file workloads as well as latency sensitive applications. Whereas the max I/O performance mode is really best for those large scale out data heavy applications. Both performance modes obviously comes with their own advantages as well as their trade-offs. In the general purpose performance mode, your general purpose performance mode offers the lowest latency per file operation, but it comes with a 7,000 I/O per second limit. While the max I/O performance mode, you have a virtually unlimited ability to scale throughput and IOPS, but it comes with slightly higher latencies per file operation as compared to the general purpose performance mode. And when to use it, as I mentioned before, we recommend that customers start with the general purpose performance mode, test their applications, but if you know that you have a large scale out type workload, we really encourage you to look into the max I/O performance mode. Again, you pick this when you create the file system. We also offer two different throughput modes. The first is the bursting throughput mode, and this is where we recommend for the majority of workloads. And in the bursting throughput mode, the throughput that you're able to drive with the file system depends on the size and scales up with the size of the file system itself. So you're able to drive 50 megabytes a second per terabyte of data stored at baseline, but then burst to double that, or 100 megabytes a second per terabyte of data stored. The second throughput mode we launched in August of this year is provision throughput. Now, customers told us they wanted the ability to drive higher levels of throughput compared to their file system size. So we launched this feature where you can actually set the throughput independent of the file system size. Again, let's compare and contrast the two options. What is it for? Again, the bursting throughput mode is our default option. It's good for workloads with variable throughput demands, whereas the provision throughput mode is really best for customers who in applications where you know you need a certain level of throughput for your application. Both, again, come with their own unique advantages as well as trade-offs. In the bursting throughput mode, again, one of our tenets, simple. And in bursting throughput mode, it's simple. Your throughput scales as the size of the file system grows. However, again, the downside is that's a fixed ratio. However, with the provision throughput mode, the advantages here is that you're able to define the throughput independent, but it comes with a little bit additional complexity in terms of pricing. It adds a pricing dimension, and we'll get to that in a second. So when to use it? We recommend the bursting throughput mode in general for most workloads. However, if you know that you have a higher throughput to storage ratio, we recommend the provision throughput mode. You can actually switch between the two throughput modes, and we'll get to that in a second. And in fact, later on during our best practices, we'll talk about when that might actually be something you would want to consider. So again, the provision throughput mode, provision of the throughput independent of the size of the file system itself. Increase as often as you'd like. And you can switch between the two modes, or you can decrease about once every 24 hours. Again, going back to our tenants, we wanted things to be as simple as possible. So when we launched Amazon EFS about 2.5 years ago, we only offered the bursting throughput mode. But we got a lot of customer feedback telling us that they wanted provision throughput, and we launched that again in August of this year. Now, customers have also told us that while they love the simplicity of Amazon EFS, it can be quite expensive to store large amounts of data for long periods of time. So we took that feedback, we looked at all the various ways that we could reduce costs while still providing the features that our customers have come to expect. So we're very excited to pre-announce this week Amazon EFS Infrequent Access, a new storage class that reduces the cost by up to 85%. Now with Amazon EFS Infrequent Access, there's no changes necessary to your existing applications. Amazon EFS offers a single file system namespace and will transparently serve that data from either the standard storage class or the infrequent access storage class to your applications. Cost savings of up to 85% for that data that is not accessed as frequently, and we offer automatic lifecycle management to simplify things. So let's talk a little bit about how that actually works. So when we launch Amazon EFS Infrequent Access, you simply create your file system. You also enable lifecycle management, and then with lifecycle management enabled, any files that are not accessed within or for 30 days are automatically moved to the infrequent access storage class. There's no need for you to manage, and you can save, like I said, up to 85%. We'll get to the pricing in a few slides. So let's switch gears a little bit. Let's talk a little bit about security and compliance. At AWS, security is always a top concern. So we offer a number of different mechanisms for you to control and secure your file systems. First, you can control network traffic using Amazon VPC security groups as well as network ACLs. You can control file and directory access using standard POSIX permissions. You can use AWS IAM for administrative access. And you can encrypt your data at rest using keys managed in AWS KMS, as well as encrypt data in transit using industry standard TLS 1.2. And because of which, Amazon EFS has become HIPAA eligible, GDPR compliant, PCI DSS, SOC, and ISO compliant. So we've talked a few minutes about the features of Amazon EFS. Let's talk about a new integration that we were very excited to announce this week as well. Some of you may have seen this week the new announcement of AWS DataSync. It combines the speed and reliability of network acceleration tools, software, with the cost effectiveness of open source tools. Fast data transfer. You can transfer data from on-premises to AWS up to 10 gigabits a second. It's very easy to use. You can use via the console, via CLI, via SDK. It's secure and reliable. It supports encryption at rest as well as in transit. And it's cost effective, only 4 cents per gigabyte. Talking about costs, let's move on to some of the economics of Amazon EFS. So there's no minimum commitment, no upfront fees. There's no need to provision storage in advance. And in fact, there's no way for one to provision storage in advance with EFS. And there's no other fees and charges. So in the default bursting throughput mode, it's simple pricing. It's only a single pricing dimension, and you only pay for the storage that you actually store on EFS. And with bursting throughput, this price includes 50 megabytes a second per terabyte of data stored, as we previously discussed. Now, with provision throughput, it adds that second pricing dimension. So the first is the storage price, like we previously talked about, whereas the second is the throughput price, and you pay separate for the throughput that you provision. And in fact, you only pay for the provision throughput amount that's above the throughput that's included in the storage price. And now, with EFS infrequent access, the data in the standard class is charged the same as we previously talked about. However, infrequently accessed data is stored in the IA storage class, and you can see the price there. It's at 4.5 cents per gigabyte. And separately, you're also charged for access. It'll be 1 cent per gigabyte for access. Let's put it back together with the slide that I talked about previously. So obviously, there's a lot of operational burden when it comes to managing this yourself. There's patching, there's managing traffic, over-procuring. Let's talk about what it actually would cost. So if you did this on AWS, you'd have to first pay for Amazon EC2 instance costs. You'd have to worry about EBS volume costs. And again, would likely have to over-provision to ensure that you had the capacity available to you. And then you also have to worry about that inter-AZ data transfer cost, again, for high availability. And additionally, with infrequent access, you would have to manage the tiering of data, if you will, between one storage option versus another storage option. And as you can see here, if you compare and contrast the two, looking at a 500 gigabyte file system, you could see that Amazon EFS is about 90% less expensive than the do-it-yourself option. And again, this is a fully managed option. There's no patching, nothing that you need to worry about for operating the file system. Amazon EFS is now available in 10 regions, and we are excited to announce that we are coming soon to the London region as well as to the GovCloud region, so stay tuned there. And with that, I'd like to pass it back to Duncan and talk a little bit more about how our customers, how they're using the service, as well as some of their use cases. Thank you.
Thanks, Vince. So now that we've had an opportunity to dive deep into some of the capabilities of EFS, let's talk a little bit about how people are using it today. So when we designed EFS, we designed it to be a general-purpose file system for the broadest array of workloads. So everything from your scale-out workloads that need massively parallel I/O and high levels of throughput, all the way down to single-threaded, latency-sensitive applications, and everything in between. And our customers are using EFS today in a very wide set of applications, which is a testament to what we've been able to do with our broad set of use cases. I'm not going to go through all of them, but I'll just pick a few to highlight. We talked earlier about the BBC moving their red button application. They actually gave a Chalk Talk session earlier in the week on it, and we have a detailed case study on their use of EFS on our website, so I'd encourage you to check that out. We've also worked with enterprise application vendors to run their applications on Amazon EFS. So Atlassian actually runs their own implementation of their Jira application using Amazon EFS. And we've worked with message broker application vendors like IBM and Tibco to get those running on EFS as well. And companies like Celgene have taken their high-performance computing workloads and moved those into the AWS cloud using Amazon EFS. But the best thing is always to hear directly from a customer. So we're delighted to have a builder here with us today. And I'm going to turn it over to Amrit from T-Mobile to hear about how T-Mobile is using Amazon EFS.
Thank you, Duncan. Thank you, Vince. It's an incredible honor to be here to talk about our use cases here at T-Mobile. So who likes to be on the world's fastest 4G LTE and on a best network and to be with and use a lower cost? How many of you here? Thanks. So that's what T-Mobile is doing. So T-Mobile is not only has re-transformed the wireless industry here, it has been through a lot of transformation over the last few years. And we have not only changed the wireless landscape, through this transformation, we have even transformed a lot of applications and whatever we have done in our data center, and we have moved a lot of things to AWS. So we have been, and AWS has played a key role in this transformation. It has enabled us to transform in a much faster phase, and EFS specifically has been part of our architecture, and it has certainly helped us to move fast. My name is Amrit Chandrasekhar. I'm from T-Mobile, and I'm also part of the Cloud Center of Excellence team. So as I told you, we not only transformed the wireless industry, we are also innovating in a very fast phase. And we use a lot of open source technology, and we would love to contribute back to it as well. And over the last few months and couple of years, we have open sourced a lot of our projects. And some of the projects are here, like the JAS serverless, which uses the Lambda functions at AWS, T-Vault, which is built on top of HashiCorp Vault for secure accessing your keys. And we have integrated with our Mesos and Kubernetes clusters at T-Mobile at a pretty large scale. Packbot, a security compliance tool, where teams have been using at T-Mobile in a large scale for knowing their compliance status. And even you can write your own rules. And it's, again, open sourced, and we have seen an incredible traction for people who are on AWS. And we are also on blockchain with Next Directory, and teams, we have been on partnership with multiple other industry folks to build the blockchain capability as well. And along with that, we are also building capabilities on Kubernetes platform, which we call as Conductor, and which we'll be trying to open source in next coming months. So the most common question, so why EFS? So we have been running a pretty large-scale container orchestration systems at T-Mobile, and we have been running with both Mesos and Kubernetes. We've been running with more than 6,000 containers, with more than 2,000 services that is running live. And we have been taking in transactions at about close to 100,000 requests per second. And we've been doing that over a lot of our NPI launches. EFS is a fully managed service. And fully managed, we don't have to worry about launching these NFS file systems on AWS and worry about scaling these AWS or pre-provisioning it. It's been fully managed. We don't have to worry about patching or any of those. It is highly scalable, as I just told. It's available on dual performance modes, general purpose and max I/O. Because we are a large enterprise company, we have a wide variety of use cases. It's also available in throughput mode with bursting and provision. And I'll be talking about these use cases and a deep dive into the architecture of how we build those systems and we are using with EFS. We take security very seriously at T-Mobile, and we choose the managed services on AWS which are in compliant, and EFS is PCI compliant as well because we deal with large number of customer data and payment data as well. And of course, it is very less expensive. It is about 70% less expensive, and now it is 90% expensive as what Vince has just talked about. So what are the use cases? So you have various architecture patterns, and one such is with Kubernetes, with CI/CD, with Artifactory, even TIBCO. And what is one thing common about all these architecture patterns is we use EFS. So EFS is central to all these architecture patterns, and I'll be talking about all these use cases now. So Kubernetes. So over this reInvent, we have seen a lot of sessions with Fargate, with EKS, and even customers are building large-scale Kubernetes environments on AWS. There are over 51% of Kubernetes clusters that are running on AWS, and we are one of them who are actually built pretty large-scale clusters on AWS. So we use EFS persistent volumes to mount the EFS to the pods directly, and we have our own customers to actually have the application teams to use EFS directly and mount it to their pods. They can provision their own EFS, or we can actually manually create EFS for them, and they can mount it. So this, even if the pods die, even if pods move between one node to another node, you don't have to worry about the persistency of data because it's been stored in EFS, and you can directly access it. And it is scalable across hundreds of nodes, and it is, as of what we have been using, it's 70% cost effective than if you're doing it on ourselves. The next use case is CI/CD. So since we are a large-scale enterprise and we're running 2,000 services, and we are into continuous integration and continuous delivery using Jenkins and any other pipelines what you're using, what we found out is it's a lot of work, and we have to maintain large systems if you're actually having Jenkins slaves on EC2 instances. And we already have a massive Mesos and Kubernetes clusters what we have built, so we started provisioning the Jenkins slaves on these clusters. And we have been doing build jobs and everything on these clusters. And what we found out that every time you are doing a build, it has to download all those dependencies like Maven dependencies or NPM dependencies and every single time, and that takes a lot of time for us to build those artifacts and then move it to Artifactory and deploy. So we have reduced our build time from 10 to 50% depending on the length of the pipeline, just because we are caching those on EFS. And every time a new Jenkins slave is spawned, it actually has these EFS mounted on these pods, So all the frequently downloaded artifacts, everything has already been pre-available on these pods. And every time you actually do a build job, it already has these artifacts. So you don't have to download over again and again. You're saving a lot of network cost and even the throughput. And even like you don't have to worry about your build jobs taking a lot of time. And I'm pretty sure nobody wants their build jobs to take about like half an hour or 1 hour to run, right? So that's exactly what we've been doing. And all our pods are short-lived. We don't have these pods running for days together. And some pods run for like a few seconds. Some pods take minutes. Some of these slaves takes even a day because of some backup jobs. And we have been through this journey over last year or so. Another use case is Artifactory. So since we are in the CI/CD and we have a centralized repository to store our Maven or Artifactory or even our Docker repositories, we use Artifactory heavily. And we want it to be highly available. And even it has to be DR, disaster recovery proof, even if one of the regions goes down or even the Artifactory goes down, we should be able to serve the nature of how applications are containerized. Every time even a new container spawn up, it has to download those dependencies, and it has to use Artifactory to download. So we leverage the max I/O and provision throughput modes of Artifactory. So we were initially trying with the default configurations of Artifactory, and what we found out was we are not able to get the maximum performance out of EFS. So it is very important for us to choose the right modes. And we chose, in last August, actually, the EFS team had released the provision throughput modes, and we make use of those. And then we actually moved some of those to EFS, and we store like more than 50,000 artifacts with 200 terabyte of data. The other use case where we actually initially started 2.5 years ago was to actually stand up TIBCO on AWS. So it's a very simple use case. All TIBCO EMS needs is a single place where it can actually have a config file. And the TIBCO EMS, the master will actually talk to this, will actually make those read and write operations on it. The slave will just read from this config file. But it just initiated our start using EFS, explore EFS with these use cases. And we were able to stand up a TIBCO EMS on AWS because of EFS. So talking to all these use cases, I'm pretty sure there's a lot of developers and architects and a lot of folks who would love to hear, how did we implement these systems? So the first architecture pattern which I'd like to talk about is on applications running on Kubernetes using EFS. So this is an architecture diagram that shows like we have Kubernetes masters and nodes. The nodes are in autoscaling group, and each of those EC2 instances are running Docker, are running Kubernetes agents. And these connect back to the Kubernetes masters. And we have EFS that is being provisioned. So each of those EFS is actually highly available, which means to say that each of those EFS, what you see in the diagram there, is built on 3 availability zones. So we mount all these EFS directly to the pods. It's up to the application teams, because application teams can provision EFS automatically in a self-service way through EFS Provisioner. So the application teams manage their own EFS, and they use EFS solutions. And since EFS is already scalable, there's no need for us to pre-provision or worry about scaling or patching or any of this. It's already available. And there are a variety of use cases teams use EFS for. And use cases like what I talked about caching, it could be one of the use cases. Our teams would like to there are some legacy systems where they have been transformed into containers, and these containers need a persistent storage, and they use EFS for that. If you're not into Kubernetes and you're into Mesos, and if you want to provision, you can actually pre-provision this EFS and directly mount those into the Docker containers. So we have a number of applications here who actually use it. So since I'm from the platform team at T-Mobile, so we actually run the Kubernetes platform, and we provide a self-service way for application teams to provision their own EFS clusters, and then they can directly mount it. So there is no need for us to have an interaction or whatsoever, because it is very simple to use EFS as such. The second use case is CI/CD. So on a very typical day, a developer comes in the morning. He wants to write code. He writes code, he checks in, and then it goes to Bitbucket. And once it goes to Bitbucket, there's a webhook that triggers, and it triggers a Jenkins job. And Jenkins requests the Kubernetes or the Mesos master to actually create a new slave. That slave gets provisioned in either of Kubernetes or the Mesos. And when it's provisioned, as I talked about earlier, it mounts these EFS to it. And that's how all the build jobs take less number of times, because it's already been cached. And now it goes through the iteration of, OK, it has to do a Maven build, it has to do a Docker build, it then pushes to Artifactory. And once it pushes to Artifactory, now it is available for it to deploy as a pod itself. And guess what? It's on the same cluster. We are not building a new cluster just because we have to run a CI/CD. We are actually using the extra space that is available in the same system. So we are actually saving a lot of cost because it's running on the same cluster. So it runs on the same cluster, and then you're deploying it. Once you deploy your services, the Kubernetes and the Mesos is going to tell it, OK, this particular pod or the container is now available for use. It has passed the health checks. Now, a user, it could be an internal or external user, if the user is actually accessing the systems through the browser or an API call using Postman or anything, it'll be going via the ingress. And then it accesses the same nodes where both the Jenkins slaves and the pod that is actually serving the application is running. So this is one such architecture pattern. The third architecture pattern is on how to build a highly available and a disaster recovery system on Artifactory. So this is our architecture. So this is exactly how we use it today and how we built it. So you can see we have like two EC2 instances that is running Artifactory. And both are using EFS mounted on these. And all the artifacts and everything is having a persistent storage on EFS. And we have RDS, and we use EBS, and even the load balancer to actually load balance the traffic between the master and slave clusters of Artifactory. We have a mission control DR application that replicates the state from one region to another region. Even if the Artifactory goes down, or even if the entire region of AWS goes down, we'll still not have any downtime, and we can provide 99.99% availability for our customers internally at T-Mobile to actually make use of Artifactory. The fourth system is the TIBCO EMS. So this particular architecture is taken from one of the architecture patterns at AWS itself. We didn't want to reinvent the wheel of how to actually build another system. So I exactly took that here, and I put it up here. So this can be found on the quick start architecture TIBCO EMS. So what you see here is you have a primary and secondary EMS server. And it's pretty straightforward. You have an EFS that has been mounted across these two EC2 instances. And it has a config file that is stored on EFS. And the primary master keeps writing those configurations and the metadata to the EFS server. And then the secondary, whenever there's a failover event or the primary master goes down, or if you're doing a patching activity on your primary, or whatever you do, and the primary goes down, the secondary TIBCO EMS already, it takes care, and that becomes a primary node. So this is one of the simple architecture patterns what we did, but this was started 2.5 years ago, just when EFS was announced. So I was initially planning to launch my own EFS cluster for one such applications. But then once I found about EFS, it was like very straightforward to use from day one. So thank you, everyone, and thanks for this opportunity. I'll pass on to Vince.
Well, thank you very much, Amreth. So I want to leave you folks with some best practices for using and testing with Amazon EFS. So in general, parallelize as much as possible. We recommend that you use multiple threads, write to multiple directories in parallel, and increase the I/O size as much as possible. And doing so will greatly improve the performance that you find on Amazon EFS. So here, let's look at throughput. In this example, we're using a single instance to write a 1 MB or 16 MB block to an EFS file system. And you can see that when we add either more threads or increase the block size of the writes, we're able to maximize the throughput from the single instance. So in this case, it's a single C5 instance able to drive the 250 megabytes a second to an EFS file system just by changing those two attributes. And just to note, the limit for a single instance throughput for a file system is in fact 250 megabytes a second. Similarly with IOPS, you can see that by increasing the number of threads, as well as by writing to multiple directories to avoid inode contention, you're dramatically able to improve the I/O per second and performance to the file system. Now, with both of these in mind, again, parallelize as much as possible. Think about the tools that you're using or how you're writing your applications. So not all file transfer applications are created equal. You can see that by using a multi-threaded application such as FP-Sync or New Parallel, you're able to drive much higher levels of throughput as compared to single-threaded applications. And additionally, as we mentioned earlier, the new AWS DataSync is a quick and is an easy way to help you transfer your data from on-premises to the AWS cloud. And I talked earlier about the two different throughput modes. And one best practice, again, is to use the throughput mode, because you're able to switch between the two. Use the throughput mode that best makes sense for the job that you're doing. So if you think about if creating a brand new file system and you're looking to ingest a large amount of data into the file system, if you choose the bursting throughput mode with no data in it, again, your file system throughput scales with the size of the file system itself. However, with no data in it, we are able to drive up to 100 megabytes a second using burst credits. And you can see that if you're looking to ingest 1 terabyte of data, it's going to take about 3 hours. However, if you're able to parallelize as well as use the provision throughput mode, you're able to dramatically reduce that. So it's a 10 times improvement there by writing from 4 instances in parallel, and you're able to achieve 1 gig a second of throughput. And just a side note, the default limit for provision throughput amount is 1 gig a second. If you require more, just please reach out to us, and we're happy to have a conversation. Other best practices, again, monitor your file system. So you can use Amazon CloudWatch to monitor the various metrics. I talked earlier about the general purpose performance mode, and you can see there that the % I/O limit is specific to that. Again, that's a metric to help you see how close you are to getting to that 7,000 I/O per second limit. Additionally, we talked a little bit about the bursting throughput mode, and you can see there's a burst credit balance that you could also monitor via Amazon CloudWatch. And in fact, this past week, the Amazon CloudWatch team just launched the new automatic dashboard. Automatic dashboards provides you with an aggregate view of the health and performance of your various AWS resources. So this is the default EFS view. With automatic dashboards, you get the insights you need really at a quick glance. If you require more in-depth or custom metrics, of course, you can use the metric math feature with Amazon CloudWatch. In fact, if you visit the EFS performance tutorial, we give a number of links and a number of suggestions to custom EFS-specific calculations to simplify monitoring as well as alarming. And then to summarize a number of best practices, again, I talked about start with the general purpose performance mode. Again, this is the one that you have to select at file system creation time. Start with the bursting throughput mode. Use a Linux kernel 4.3 or greater. Utilize the EFS mount helper, and really this is a wrapper that's executed to help you mount the file system with NFS 4.1 as well as with the default recommended mount options. And as I talked about, large I/O size and parallelize as much as possible. Multiple threads, multiple instances, write to multiple directories to avoid inode contention, and then monitor those metrics. So to close out, you can quickly create a scalable, high-performing file system. Visit the AWS website. You could also take a look at some of our tutorials. The examples that I showed previously in the best practice section, you could actually walk through those yourself. So visit the AWS website, and you can take a look at a lot of those. And with that, I'd love to take any questions that you might have. We're very fortunate to have Amrith here, so we're happy to take any questions about EFS or any questions for how T-Mobile is using the file system. Yes, sir. Yeah. Coming soon. Coming soon. Yes, it's a very important feature, and it's one that customers have asked us quite frequently for. So we're happy to pre-announce it, and you may have seen it in Andy's keynote yesterday, but it is coming soon. I'm sorry, sir? Yes. So you are able to drive your performance scales as your file system size grows. In the bursting throughput mode, you're able to drive up to 3 gigs a second, depending on the region, or 1 gig a second, again, depending on that region. But again, it's depending on the size of your file system itself. Whereas with the provision throughput mode, you just set the provisioned amount to what you would like, and again, you just have the two different pricing dimensions. Yes, sir.
Everything what you described in terms of features, performance, same applies to Windows?
So
Sure. So the question was about if the same things that we've just talked about with Amazon EFS applied to our new Windows file system. So the Amazon FSx for Windows File Server is a completely different service offering. It's designed for a different set of use cases, and they do have their own performance features and their own pricing as well. So it is separate from Amazon EFS. Lustre as well. Amazon FSx for Lustre, also a separate service. Each one tuned for slightly different performance workloads, and each has its own set of features and its own separate pricing.
Yes, sir.
Yeah, so I recently ran into an issue with EFS where I slowly ran out of burst credits over the course of like 6 months, and then everything stopped working at one time. And when I contacted support, an alternative suggestion they gave me to switching burst mode was to just DD a huge file. Any reason why not just to go to provision mode instead of DD? So that's what I did. Provision mode. Is there any benefit to just DDing a huge file to like fake provisioning much data?
Yep, so if I understand your question, is you had an issue where you were slowly running out of burst credits, and someone recommended that you just add some padding data to your file system so that you're able to achieve the throughput that you're looking for. Correct. Like I previously mentioned, when we launched EFS, we want to make it as simple as possible, so we only had that single bursting throughput mode. So what we in fact recommended for customers to do is, if you knew that you needed a certain throughput amount, was to do something similar to what you just did, which is again just to ensure that you had your file system size was of the appropriate size. So there are a number of different ways you could do that. DD obviously was one that obviously worked in your use case, but obviously with provision throughput, you no longer need to do that. So absolutely, you could just use provision throughput. You can switch at any time. You don't even need to create a new file system. Yeah, that answer your question, sir? Great.
Any thoughts on accessing EFS on Windows box similar to Starbucks?
So the question was about accessing an EFS file system from a Windows box. It is an NFS file system, so it's available from an NFS v4 client. What we found in talking to a lot of customers over the last year, because we get asked about Windows a lot, was that the needs of our Windows customers were often quite unique and distinct, and that's why we developed and announced yesterday FSx for Windows File Server. So right now, with Amazon EFS, we continue to be very focused on NFS and primarily Linux workloads.
We have another service on-premise, and we have it on AWS. Are there any caching mechanisms, just like storage gateway, you're thinking of so that you cache the local data there and then move back and forth kind of a thing?
Well, Amazon EFS itself does not offer a caching mechanism today, but we are integrated with Amazon AWS Direct Connect for high-speed access into AWS, and we just announced a few weeks ago that we're now supporting AWS VPN for access from on-prem into EFS as well.
I think there was a question here. Yeah.
Can you share your plans to support EFS under Fargate?
You go ahead.
Okay, that's a very common request, customer feedback. We take customer feedback very seriously. As we mentioned, we launched a number of new features this year. We don't publicly comment on our roadmap, but if you'd like, we could take this offline and have a more in-depth discussion, perhaps in a more different venue. Are there any questions for Amreth on his use of EFS and how T-Mobile is able to achieve success? Are there any other questions in general? Yes, sir. I'm sorry, can you say that one more time, sir?
I was in a session yesterday about storage gateway, and storage gateway from a caching point of view, it's great for S3 and EBS. Neurosis would be a perfect solution for this
Well, again, that's something that gets into really talking about our roadmap going forward, which is something we typically don't do in a public session. Certainly, though, we appreciate hearing that feedback. That is something that we hear from folks. We do have, as Vince talked about, the new AWS DataSync service for moving and ingesting data into EFS directly, and that supports both S3 and EFS natively.
Yes, sir.
So the lifecycle management feature is part of the new EFS infrequent access storage class. So we've announced that as coming soon. So it's not yet available for people to use, but we hope to get it into customers' hands very, very soon. And lifecycle management for newly created file systems, once it becomes available, you can turn it on, and then we'll automatically move the infrequently accessed data after 30 days to the IA storage class.
Yes, sir. Yeah, absolutely. In general, like I mentioned, the best practices, you'll typically get better performance if you increase that I/O size. One of the key benefits of Amazon EFS is that we, durably store your data across multiple availability zones. We support strong consistency, so that any subsequent, when you close the file, any subsequent opens is immediately accessible. That data is immediately accessible. Due to which there's a small latency overhead associated with each file operation. So in general, if you're able to increase the I/O size, you'll be able to get better performance because that latency overhead is amortized over a larger set of data. Totally understand. It's like I said, in general, if you're able to increase the file size, you'll get better performance. But maybe we could take this offline, and I'm happy to share a little bit more and learn a little bit more about your specific use case. Yes, sir.
Well, the use of Redis with EFS is something we'd love to learn more about your specific use case from. We're always looking for feedback like that, so we'd love to have a conversation at the end of the session about that with you and learn more.
I think you had a question, sir?
Yeah, one of the, it's a welcome move that you guys have what you call infrequent access.
Mm-hmm.
The main reason why we built our own InFS cluster is for the cost advantages.
Mm-hmm.
And are there any thoughts or any ideas to move into Glacier or S3 down the line? Not 4.5 cents per gig is good, but when compared to 3 or 1, that's even better. We thought the same.
So again, we'd be getting into things in terms of the roadmap, which we typically don't talk about in a public forum. Right now, we're very excited to get infrequent access out the door and into customers' hands, and we'll be listening intently to all the feedback we get about where customers would like us to go from there. Yes, sir.
What are the considerations to use EFS versus not being in this product?
Well, EFS is designed where you want to have a file system, a live file system available. It's designed to be a drop-in replacement for applications and use cases today that expect to have access to a file system and conduct file system operations. So that would be the primary use case for EFS today.
And there are a number of considerations. S3 is a fantastic service, obviously, and one of the things that we like to recommend is use the right tool for the workload or the job that you're doing, right? While taking into consideration the subtle differences between the various services. So for example, one thing is that S3 is eventually consistent, whereas EFS offers strong consistency. So for some customers, that doesn't matter. For other customers and other workloads, like I have to have one or the other. So again, it all depends on, it's an it depends sort of question.
You have a list that compares all those points, EFS and S3, how does it pick the right one?
We don't have a standard list that says, hey, pick A versus pick B, but we can talk offline. I'd love to learn a little bit more about your particular use case, and then maybe I can help you with that journey. Cool? Yes, sir.
We use both. So yeah, so but EFS, so in case of disaster recovery and all those cases, we use EFS extensively for those.
Because for frequently accessed files, I think every time to go to EFS will be as slow and
So that's the reason why we have the throughput mode, that we have a higher throughput mode provision. So that was announced last August. So if you actually go with the default mode, so that's going to be a very high, even more high latency, and it's going to be slower for us. So that's why we pre-provisioned a lot of these.
Okay. Well, thank you very much, folks. I know you guys have a number of different sessions, too, that you could choose from, so we're very honored that you guys spent your time with us. As always, thank you again, and please fill out the survey, and hope you guys enjoy the rest of your conference. Thank you very much, folks.